Okay, good morning. This is Mrs. Hunsucker. Today we're covering section 309, and I'm going to ask that each of you watch the instruction module for 309. It's so important that you do this. It contains excellent proof examples, and well, you can't avoid them. So take a look. Um, they go through each step that I think is very well explained and easy to understand. The big concept in this lesson is CPCTC. You may have heard of me say it in class before. Now, CPCTC, the C represents corresponding. And then the P represents parts. Okay? This should be of, congruent, triangles, are congruent. Let me see if I can erase just that part. Let me do pink again. Let me do darker blue for triangles. And then this green for congruent. So corresponding parts of congruent triangles are congruent. When do you use this? Why do you need it? You use only after you know two triangles congruent. So what does that mean? Use after using side, angle, side, 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 angle, side, angle, side, angle, angle, or HL, hypotenuse leg. So once you make a congruent statement saying one triangle is congruent to another, you're going to use that to say two sides or two pairs of angles are congruent that you haven't already stated in the proof somewhere else. All right. All right, let's look at this diagram, okay? We have two triangles, LNM and triangle PNO. Or we can say, I said LNM, so I'm going to go PNO, okay? The order does matter. If I say LN, I'm tracing the side with one congruent mark. So I must start with P and trace the side to N with one congruent mark, okay? The blank congruency theorem can be used to prove triangle blank is congruent to triangle blank. Okay, so far we have two pairs of sides given to us as congruent. Okay, remember to prove triangles congruent that involve two pairs of sides, we either have side, angle, side, or side, side, side. The others are angle, side, angle, side, angle, side, and HL. Well, that's not the case. Actually, I already said side angle side, so let me erase that. I erased everything. All right, so we have two pairs of sides. So side, 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 it could possibly be, could be side, angle, side. The others are angle, side, angle, that's one pair of sides. Side, angle, angle, two pairs of angles, and then hypotenuse, leg, which is for right triangles only. So what do we think? We have two lines intersecting, okay? And what type of angles are formed by intersecting lines? So for example, we have LP intersecting OM, okay? Now we have those two angles that have just a common vertex O, okay? Those are called vertical angles. So I'm going to say that LNM is congruent to PNO, okay, by the vertical angles theorem. Okay, so let me go ahead and say that angle LNM is congruent or equal to, I don't have a congruent symbol, so I have to always type it out, to angle. Now let's make sure we match up corresponding vertices, because I start with L, so I have to match up the corresponding vertex, which is P, and then N, and then O. And they're congruent because of vertical angles. All right, so now I have triangle LNM congruent to triangle PNO by side angle side. Now notice the angles PNO and LNO are the included angles. And what I mean by that is if you take side LN and MN, the included angle is the angle formed by those two sides. It's kind of in between the sides. It's the angle formed by congruent sides. All right, so the side angle side congruency theorem proves the triangle's congruent. So to fill in the blank here, and then proves triangle ONP. It says ONP. So I have to start with MNP. If I start with O and trace to N, that's the side with two tick marks. So I have to call it MNL. Okay, so that's what I'm going to put right here. All right. Moving on. Let me erase all this. It says, consider the diagram. The congruence theorem that can be used to prove triangle LON is congruent to LMN is, well, let's use process of elimination. Okay. We have two pairs of sides so far, and it's not a right triangle, so no HL. We don't have two pairs of angles. We have angle side angles, only one pair of sides. We already have two. So it's either going to be side angle side or side side side. Okay? But if you notice, both triangles share LN. That's another pair of sides. So we can say LN is congruent to LN. LN is in both triangles. So that's a pair of sides. And whenever you say a segment is congruent to itself or an angle is congruent to itself, it's the reflexive property. Okay, so the triangles are now congruent by side, side, side. All right. All right. Now this one gets a little bit interesting. Okay. But I want you to look at, let me see. I want you to look at triangle TZV. And triangle UWX. Which is right here. And if you look, angle T is congruent to angle W. So that's a pair of angles, okay? All right, remember the ways we prove triangles congruent, okay? Side, 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 angle, side, angle, side, angle, side angle, angle, or HL. We know we don't have right triangles, so it's not going to be HL. We should also notice that angle T is congruent to angle U. I don't know where I got W from. Angle T is congruent to angle U, excuse me. All right, now, let me then go on to say that angle V is congruent to angle W. Angle V is congruent to angle W. All right, and that's another pair of angles. So think about it. What triangle congruence theorems do we have so far if we have two pairs of angles? It's either going to be side angle angle or angle side angle, okay? So we can eliminate some choices here. We can eliminate side, side, side. We can eliminate side angle side. So it's either choice B or Z. Okay, now, if we look, UV overlaps, okay, in both triangles, okay? So we can say the bottom side in the red triangle is TU plus UV. And that will equal WV because first of all, TU and WV are equal, okay? So we can say TU plus UV is equal to itself, is equal to WV plus UV. Now take a look at that. You can subtract UV from both sides, right? And when you do that, you're left with TU equals WV. Let me back up. What's T? Oh. All right, let me do this again. All right, TU plus UV equals WV plus UV. And if you look at TU plus UV, that's the whole side, TV. And then WV The smaller parts of the segment WV plus UV make up the entire blue base there, UW. All right. And if UW equals TV, that's a pair of sides in the red and blue triangles. So what do we have? The triangles are congruent by angle, side, angle. Okay, so the answer is C. All right, moving on. Okay, looking at this last proof, it says that JP, and it's hard to mark, JP is equal to KP. JP and KP. Okay, so the two triangles that we're going to try to prove congruent are JPY and KPY. Okay? And it's saying that JP equals KP. JP equals KP. So if I draw, let's say, this line right here for KP, that whole side is congruent to JP. That whole side. Now, and then it says PX is congruent to PY. That's a pair of bases, okay, in both triangles. Okay. So far we have two pairs of sides congruent. All right, so let's go over to the proof. And it says that JP equals KP and PX equals PY. That means those segments are equal in length. If two segments are equal in length, we can say they're congruent as well. That's the definition of congruence. Definition of congruence says if two segments or two angles are equal in measure, then they're congruent. Now it says angle JPK. Angle JPK, which is right here, is congruent to angle JPK. See this angle down here? It's shared by both triangles. So whenever something's congruent to itself, that's the reflexive property. Okay, now why are the triangles congruent? So let me just go ahead real quickly. We can say, all right, this angle is congruent to itself in both triangles, so the triangles are congruent by side, angle, side. All right, so go ahead and take your 309 quiz and have a good day.